So the last video we looked at keying in a horizontal alignment directly from the engineer's drawings. Now we're looking at keying in a vertical alignment from the engineer's drawings. And the left-hand side of the screen here, you're seeing a typical engineer's drawings as we get them from an engineer's drawing for the vertical alignment as we get them in the UK. So we're basically given the start of the road, the starting level. We're then given grades. We're given the details of the symmetrical parabolas. So we're given the K factors and so on, curve lengths, all the way through that road alignment. And to key this in a neat form in Trimble Business Centre, again, it's very crucial to get the settings correct that suit the way that we've been given the data. So in the alignment editor, we can see that I've changed it to by curve definition by length, and you'll see why I like the segment slope to be the key information that we key into the road. So point beginning, chainage 0, elevation 22.65. We can then put in our first symmetrical curve, and we're giving it basically a chainage of the midpoint of the parabola. So here it is basically, we're given a chainage of 49.5. The curve length is 15, so half of that is 7.5, plus this gives us a chainage of 57 for the center of that symmetrical parabola. And then we can put in the slope, and we can put the slope here as 1.093, and the curve length is 15. And the elevation that's given here is basically the elevation of the vertical point of intersection. So this elevation will not actually fall on the road itself. It is the intersection of the grade going into it and the grade going out of that parabola. We can then, while the other thing I want to emphasize here is that while the symmetrical curve, the first element is a symmetrical curve, the curve length is 15. So the road geometry will be basically a straight grade up until chainage 57 less 7.5. We do not need to put in this element here, 49.5, as a grade break. We just go from symmetrical curve to symmetrical curve, and we'll put the straight grades in between them as required. So the next symmetrical vertical curve is this one here, which we can see is chainage 49.5. We need to put in the midpoint, so it's 7.5 plus that because the length is 15. So the chainage is 77. The slope going into it is minus 1.250, so we can enter that. And again, the curve length is 15. And then we can go all the way through to the next one. So this chainage is 139.799 plus 7.5 again. So that's 139.299. And the slope going into it is 4.815. And again, the curve length is 15. And then we have a straight grade, and this is where we need to put in a point at the end, whereby we have at 240, which is the last point we're given, then we have a height of 27.311. And we just want to check that things make sense, so we can check that the K factors have been calculated correctly. So this point here, 6.403, yep, looks pretty good. This one here, 2.473, again, that looks good. And the K factor here, we have of 0.666. So I was puzzling over this K factor of 0.666, and what I've done, of course, wrong here is I've put in the level as the grade instead of the grade. So that should be 1.322. The K factor is now 4.294, so that's very close to what we've got here. What we'd also like to do is go up to the top here and do more reports, go into the reports option, more reports, alignment geometry report. That will generate a nice report, which we can see here at the right hand side of the screen. And then what we can now do is check the detailed horizontal alignment and vertical alignment levels. So the ones I want to check are the start and end of curves and also the high points, which are all given in the drawing. So if I just zoom into the drawing here, I can see that the start point is drainage of this first vertical curve is 49.5. The elevation is to 23.168. That's fine. We then have the high point on the vertical curve of drainage 56.497. And again, within 1 millimeter there. And the level there is spot on to the millimeter. And then we have the end point of that at 64.5, which again corresponds there, and the level is spot on. And then we can go to the next vertical curve here, starting at 69.5, which is correct, 23.088. So we've got a 6 mil difference there. So it could just be between rounding on the grades, I would guess, is what's happening there. And then we've got the end of that at 84.5, and again, the level spot on there. And then the high point, or low point in this case, is 72.592 with a level of 23.074. So we can go through and check our road geometry that it's matching what's in the engineer's drawing. So that's a quick video on how we enter the vertical curve geometry into the alignment in TBC from typical engineering drawings in the UK.